This next series of videos will deal with proofs using the ASA and the AAS triangle congruence theorems. So let's take a look at our first example. So we're given that WT bisects NP, and we want to prove that these two triangles are congruent. So first things first, we need to name the triangles. So if I start with angle N here as one of the sides in my triangle, the corresponding angle, well, in this second triangle, we have a choice. It's either going to be T or it's going to be P, and how will we know? Well, angle N is created by this long parallel side and then this long side connecting to E. And likewise, angle P is made from this parallel side and the long side connecting to E. So N corresponds with P. And from there, we can kind of piece together the rest. If we go from N to E and end up at W, then again, we can start at P, head toward E, end up at T. So please also note that we have these arrows on segment PT, on segment PT and on segment NW, and those arrows indicate parallel lines. So that's other given information. NW is parallel to PT. So how are we going to go about proving this? We need to prove that these two triangles are congruent, and, well, we're missing some stuff. Right? We can prove triangles are congruent using SSS, SAS, ASA, and AAS. And right now we have no sides congruent and no angles congruent. So let's piece a few things together. Let's take a look at this given statement, the fact that WT bisects NP. So WT is doing the bisecting, but NP is being bisected. NP refers to this long segment, and we know that that segment is bisected, or in other words, it's cut into two equal parts, and WT is doing that cutting. Secondly, we have these parallel lines, and parallel lines, well, if we consider these parallel lines cut by the red transversal, then angle P and angle N would be considered alternate interior angles. And then finally, the way that these two triangles are drawn, we have intersecting lines, or intersecting line segments, and intersecting line segments create vertical angles. So we've got the blue angles, the red segments, and the green angles means that we can prove using the ASA theorem. So let's get to it. Let's write our proof. So right away, we know that the given statements, well, the given statements are there, but the proof statement, that's what we're trying to prove, so that goes in that last box down here. And in the previous slide, we ascertained that we're going to use the ASA theorem to prove that. And so we need to talk about which pair of angles, which pair of sides, and which pair of angles are congruent in order to prove that the triangles are congruent. Well, we've established that angle N, angle N is congruent to angle P. And the reason why is we had those parallel lines, NW and PT. Next, we need to talk about the segments that we had congruent. We knew that NE and PE were congruent. And that came from the fact that WT bisects NP. And then finally, we had our vertical angles. And those come from the fact that, well, we have intersecting lines because of the way that this particular figure is drawn. So those vertical angles are always congruent, which means angle NEW is congruent to angle PET. And so there's our proof. We're done. Just scroll down a little bit so you can see everything. So, by the way, with this particular proof, there's another way to go about proving it. And that proof, a second way of proving it does not use these vertical angles. And so all of this blue information we actually wouldn't use. And so instead of the blue angles at NEW and PET, we can still use the fact that NW and PT are parallel, right, these segments. And that tells me that alternate interior angles are congruent. Well, angle W and angle T are also alternate interior angles. So we could use that information for the proof as well. The difference is, instead of using ASA, we would be using AAS. And here's why. In AAS, the pair of sides, I guess, that are congruent are the non-included sides. And so if we just consider triangle NEW, let me pull that out for a second. If we just consider triangle NEW, we know that these segments are going to be used, or that segment, I guess, this angle and this angle. Those are the used segments and the used angles in that proof. And you'll notice that the red segment is only connected to one of the angles. Right? It's only connected directly to that angle N. So we'll be using AAS. So let's do a little bit of rearranging of our proof. So since we're dealing with an angle side proof, we'll have to talk about one pair of angles, which is shown here, another pair of angles, and then that pair of sides that we've already established. Okay, so from the fact that NW is parallel to PT, that gave us this first pair of angles, that N and P were congruent. Now we also established that angle W was congruent to angle T. And the reason why is the exact same reason as N and P are congruent. It's the same pair of parallel lines, but different transversal. And so the fact that NW is parallel to PT also gives us angle W and angle T congruent. And so that gives us our proof, which is similar to the previous proof, slightly different. It's using the AAS instead of the ASA. So I guess we've just established there's more than one way to prove this particular statement. All right, next example. We're given that GO and LF are parallel, OL and GF are parallel, and our job is to prove that G and L are congruent angles. So the sub-step, or the step kind of before proving this is true, is we'll want to prove that the two triangles are congruent. So we're going to start by proving the triangles are congruent, and then we can use the CP-CTC, like we've seen before, to prove that angle G and angle L are congruent. So first off, let's kind of figure out what we have here. These segments are parallel, GO and LF, and that refers to GO and LF. Well, what of it? Well, with parallel lines, you should always be thinking about angles. And in particular, well, which pair of angles? Those yellow lines are parallel, and they are cut by this transversal, OF. So if we've got parallel lines here, cut by a transversal, we're thinking about angles. And in particular, the only angles that touch those yellow lines are angles 1 and 4. So GO parallel to LF, that gives us angle 1 congruent to angle 4. Next piece of given information is that OL is parallel to GF. OL refers to this segment, GF refers to this segment, and they're still cut by that red transversal. However, the angles that are congruent because of that fact are different. Angle 2 is created by a green line. Angle 3 is created by a green line. And so that means that angles 2 and 3 are congruent because OL is parallel to GF. So we've got two pairs of angles. the way that this particular image is drawn, we've got a shared segment, OL. And since we have two pairs of angles, we can either use AAS or ASA. Oh, ASA. But which one is right for us? Well, we've got to think about the included side. If you just consider triangle GOF, I'll just recreate it down here, GOF. So that's this triangle in here. Oh, that triangle. So if we just look at that triangle, we've got angle 1 up top here. We've got angle 3 down below here. And then we have that shared segment right in the middle. And so this follows angle, side, included side, angle. So we must use the ASA theorem and can't use AAS. So let's get to it. Let's write the proof. All right, so earlier we talked about using the two triangles congruent as a sub-step along the way. So we want to use the fact that GOF and LFO are congruent first. And however, the proof itself, remember, asked us to prove that angles G and L are congruent. And so once we've established that the two triangles themselves are congruent, we can use the CP-CTC to say that angles G and L are congruent. All right, so now let's get back to the bulk of the proof up above. We need to talk about a pair of angles, a pair of sides, and another pair of angles. From the given information, we know GO and LF are parallel, which meant angles 1 and 4 were congruent. Similarly, because OL is parallel to GF, angles 2 and angle 3 are congruent. And then lastly, OF is a shared segment in both triangles, and as a result, it'd be congruent in both GOF and LFO. So now our proof is done. Scroll through it so you can take a look at the final proof. It kind of looks like a 6, doesn't it? It should be a G. All right, here we have our final example for the day. We've got a goal of proving that MN and EA are congruent. Now, in order to do that, we're going to have to prove that the two triangles are congruent. So those two triangles, let's name them. So once again, proving that these triangles are congruent is going to be kind of a sub-goal in order to prove that these segments are congruent using the CP-CTC. So let's piece this together. Which of our triangle congruence theorems can we use? We know that MN is parallel to EA. So MN and EA are parallel. And what that tells me is any angles that are created by those segments will be congruent, either congruent or supplementary. So if we consider MN and EA, and they're cut by that transversal, then the angles that created them, sorry, not that created them, but the angles that are created, if we look down at these angles, we've got angle 2 and angle M would be considered corresponding angles. So those are congruent. So that fact tells me that angle 2 is congruent to angle M. We have given information that N is congruent to A, so this angle and that angle are congruent. And then lastly, E is the midpoint of MG. Well, what does midpoint mean? Midpoint is the middle point. So here's MG, and E is right in the middle. In other words, that segment, ME, has to be congruent to EG. So now in these triangles, let's just pull out one of those triangles. In these triangles, we are given that these blue angles are congruent. So that's angle M and angle 2. We're given that these green angles are congruent, angle N, angle A. And then finally, we've got that midpoint segment, or that midpoint of a segment, which means that these segments are congruent. So we've got the green, the blue, and the red. We can either talk about angle, angle, side, or angle, side, angle. And how do we pick? Well, in angle, side, angle, this side must be the included side. In this triangle, this side with the red tick marks is not the included side because it only touches that blue angle. It has nothing to do with this green angle over here. So as a result, we're not going to use angle, side, angle. We must use angle, angle, side in order to prove that the triangles are congruent. So let's get started. We know since we're proving that segments are congruent, we must first prove that the triangles are congruent. And then once we know all the triangles are congruent, from that information, we can then prove what it is we're trying to prove, specifically that MN is congruent to EA. So hopefully these last two steps, let's call this like step 1, step 2, hopefully these last two steps are looking familiar to you. First, proving that the triangles are congruent, and then second, using that congruence to prove that the segments or the angles or some parts of the triangles are congruent. All right, now since we're using the angle, angle, side theorem, we need to talk about which pair of angles, which pair of other angles, and then which pair of sides are congruent. Well, we can just start in order of the given information. We know that MN is parallel to EA. So MN is parallel to EA, and we saw that that gave us these corresponding angles are congruent. So angle 2 and angle M are congruent. So parallel lines make corresponding angles congruent. Next, we could take a look at the next piece of given information says angle N and angle A are congruent. And so that can go in our next box. And we need no statement above that box because that was given information. So we don't need to explain why it is because, well, that's just given to us. And then finally, the segments. We knew that ME and EG were congruent. And the reason was E is the midpoint of MG. And midpoint means midpoint, middle point. It's splitting up the segment into two equal parts. And so that midpoint definition will give us that information. All right, and now I think we're done with this proof. All of our given information is used up. Here we've got the green is used, the blue is used, and the red is used. And we've proven first that the triangles are congruent, and then using the CPCTC that the segments are congruent. So we're all done.